Hello students. So today we are going to start with the revision series. Okay, you can do your revision with me. So we'll be starting with the questions which are 1 mark questions. Okay, so let's start. Okay, so I'll be revising all the questions which are asked, means which are likely to be asked for CBSE level also and Goa board also. Okay, so 1 mark questions. So let's do first question. Evaluate integral sin x minus cos x upon root of 1 minus sin 2x dx. Okay, so integral. So here you can see that 1 minus sin 2x is given, so you have to use the trigonometric identity sin 2x, which is 2 sin x into cos x. Okay, I'll write here sin x minus cos x upon root of 1 minus 2 sin x into cos x, right? So now this 1 you can write it as cos square x plus sin square x, correct? So I'll directly write here and the remaining term is minus 2 sin 2x into cos x. Now sin, looking at this term, you'll realize that this is cos x minus sin x the whole square, right? Or you can write sin x minus cos x the whole square. Okay, both way it is true. So taking under root sin x minus cos x the whole square. So if you expand this, you will get sin square x plus cos square x or sin square x minus 2 sin x into cos x plus cos square x. Okay, so this root and square gets cancelled, so we'll get here integral sin x minus cos x upon sin x minus cos x dx. So this gets cancelled and you will get integral of 1 dx, which is your x plus c. Okay, let's solve second question. You have to evaluate the matrix product. Okay, matrix are given 1 2 minus 1 1 minus 2 minus 1. Okay, so first you have to write the order of these two matrices. So this is your 3 cross 1 and this is 1 cross 3. So whatever matrix you will get, it is of the form 3 cross 3, correct? So that way you have to find out the product. So 1, that is this column into row, 1 into 1 1, then 1 into minus 2 minus 2, 1 into minus 1 minus 1, 2 into 1 2, 2 into minus 2 minus 4, 2 into minus 1 minus 2, this is minus 1 plus 2 and 1. Okay, this is 3 by 3 matrix. This is the answer. Let's solve this. So it is given y equal to root of x. Okay, so you have to find dy by dx. So this y you can write it as root x into x raised to half. Okay, so here x raised to 1 is there. Using laws of exponents, you will get this as x raised to 1 plus half. Now 1 plus half is 3 by 2. Okay, and this will be x 3 by 2 raised to half. Okay, so again using laws of exponents, this gets multiplied with this, so it will be 3 by 4. Now you can find the derivative. So dy by dx, derivative is what? You have to find n x raised to n minus 1. So n is your 3 by 4. So 3 by 4 x raised to 3 by 4 minus 1. So cross multiplying, you will get minus 1 by 4. So this is the answer. Okay. So this is the question. Find the slope of the tangent to the curve y equal to e raised to 2x at point 0, 1. Okay. So slope is given by the derivative, right? So dy by dx is what? 2 e raised to 2x. Okay. E raised to 2x derivative is e raised to 2x, and then you have to write the derivative of 2x, which is 2. Okay. Now you have to find the slope at the point 0, 1. So at the point 0, 1, slope will be 0, 1. So you have to substitute x and y. So your x value is 0. So 2 e raised to 2 into 0, 0. E raised to 0 is 1. So your answer is 2. Okay. So this is the question. You have to find the direction cosines of the normal to the plane. So equation of the plane is given, and this is in the Cartesian form. Okay. So this is in the form Lx plus My plus Nz equal to D. So this becomes your distance. These are L, M and N. But here it is not in the proper way. That is, L, M, N are the direction cosines. But here 1, 2 and minus 3 are your direction ratios. You have to write it in the proper form. That is, you have to find the magnitude. This is 1, 2 and minus 3. So you will get root of 1 square, 2 square is 4 and 3 square is 9. So you will get 5, 9, 40. So 1 upon root 40. So your direction cosines are 1 upon root 14, then 2 upon root 14 and minus 3 upon root 14. Okay, this is the answer. This is the question given. You have to find the degree and the order of the differential equation. So differential equation is given: d square s by dt square raised to cube 3 ds by dt the whole square plus 5 equal to 0. Now your order is the highest order derivative you have to see. So here highest order derivative is d square s by dt square, right? So its order is 2. Now degree is what? It's the degree of the highest order derivative. So highest order derivative is this, and the degree of this is 3. So degree is 3. Okay, this is the solution. Okay, so here it is given that if A and B are mutually exclusive events, okay, you have to find P of A union B. Now if A and B are mutually exclusive events, then its intersection, that is probability of intersection, is 0, right? So if you use the formula P of A union B, okay, which is our P of A plus P of B minus P of A intersection B. So if you substitute this value here, so you will get P of A plus P of B when A and B are mutually exclusive events. So this is the answer. Okay. So here they have dy by dx you have to find, and y is given as sine cot inverse of x plus tan inverse of x. Now this question is a combination of inverse trigonometric functions plus derivatives. Okay, so first you have to write y sine. We know that through properties of inverse trigonometric functions that cot inverse of x plus tan inverse of x is pi by 2. So you can directly write here pi by 2, and sine pi by 2 is 1. Okay, so y is equal to 1. So dy by dx, that is derivative, is 0. Okay. So this question is from matrices. So this is the matrices are given equal. So we know that whenever one matrix is equal to another matrix, then the corresponding elements are equal. Okay, so you have to find x minus y plus z, and condition is given y is less than 0. Okay, because here y square is given. Okay, first we'll compare the numbers. Okay, so x is equal to 1, z is equal to 2, and y square is equal to 4. So your y has two values, plus or minus 2, correct? And condition is given y is less than 0. So you have to take y equal to minus 2. Okay, not plus 2. So substituting in x minus y plus z, you will get 1 minus of minus 2 plus 2. So this is 1 plus 2 plus 2. So this is 5. 5 is the answer. Okay. Next question. So you have to find degree and order of this differential equation. Okay. Here cube root is given. So when you take cube on both the sides, you will get d square y by dx square cube, and this cube and cube root gets cancelled, so you will get 1 minus dy by dx raised to 4. Okay, now looking at this, you will find that this is your highest order derivative, so your order is 2 and highest order derivative's degree is 3. Okay, let's solve this. So this is here y is given. You have to find out the dy by dx and show it equal to y sec of x. Okay, so starting with y sec of x plus tan of x, write the derivative of sec of x, which is sec of x into tan of x. Okay, plus derivative of tan of x is sec square x. Okay, if you take common here sec of x, you will get tan of x plus sec of x. Now this term is our y, so you have to substitute here y, so you will get y sec of x, which is our desired result. Okay, now here the question is given if a and b are two independent events. Okay, and information which is given is p of a intersection b is 1 by 3, p of a is half. You have to find p of b complement. Okay, so using the information that is a and b are independent events, we can write p of a intersection b is p of a into p of b, right? So from this you will find the value of p of b. So 1 by 3 equal to 1 by 2 into p of b. So your p of b is 1 by 3 into 2 by 1. So this is 2 by 3. Okay, and p of b complement is 1 minus 2 upon 3. So this is 3 minus 2 upon 3. So it is 1 by 3. This is your p of b complement. Okay,